We are looking at block 4 of topic 3 and patterns in proportional relationships. And we're continuing to look at what makes a proportional relationship versus a non-proportional relationship. So let's take a look at these two tables here for number 1. And it says, consider the tables representing the costs of pizza with delivery and the cost of pizzas without a delivery charge. So our first one you can see here is a pizzas without delivery. So if it is without delivery, then the number of pizzas is 1. The cost in dollars is 7. And so we divide the cost by the pizza and the number of pizzas, and we get 7. In the next row, we have the cost is $14 and divided by 2 pizzas, the cost is $7. In the third row, there are 3 pizzas for $21. So when we divide 21 by 3, you get 7. And the last row, 4 pizzas is $28. So we divide 28 by 4 and we get 7. Now, when we look at question A down here, it says complete the table for pizzas with delivery by filling in the quotients. What do you notice about these quotients? Well, you'll notice that every time we divide the cost by the number of pizzas, we get the exact same quotient every time. So we can say that the quotients are equivalent, because they work out to be the same every time, no matter which row it is. Right? They are equivalent. Now, let's take a look at the table for pizzas that what do we notice about the other table, the pizzas with the delivery charge? And I think I might have A and B mixed up, but that's okay. We'll sort it out. So now we're looking at pizzas with a delivery cost. So here we go. The cost for one pizza is 12 divided by 1. Well, that's 12. Perfect. All right. The next one, the cost is 19. We divide by 2. 19 divided by 2 is 9.5. The next one, we divide the cost, which is 26, by 3 pizzas. 26 divided by 3 is 8.6. And let's see, we would round that to the nearest cent, which would be 8.67. And the last one is 33 divided by 4 pizzas. And that is 8.25. Let me double check that. 33 divided by 4. Yep. So as you can see, when we divide those, how are the quotients in that section? How do they work out? Well, obviously, they are not equivalent every time. So that's exactly what we'll say. The quotients are not equivalent. And that's easy to see. And that's important because one of those represents a proportional relationship. And the other one represents a non-proportional relationship. And that's going to be important, obviously. So now let's look at these graphs and algebraic rules for the same two pizza scenarios. All right. You can see here that at the bottom of the first graph, and it says that this one is proportional. And at the bottom, you can see that the number of the equation for this is the cost in dollars is equal to 7 multiplied by the number of pizzas. And the one next to it is a non-proportional graph. And the equation for it is y equals 5 plus $7 multiplied by the number of pizzas. Now, I want you to also notice that in the first graph that is proportional, that line crosses the y-axis right through the origin at 0, 0. That's how you know that one's proportional for sure. But you'll notice that this one does not cross the y-axis at the origin. That crosses the y-axis at 0, 5. And that is definitely not proportional. It has to cross through the origin in order for it to be proportional. Okay? Now, if we're looking at these graphs and the tables that were on the page before it, you'll begin to notice a certain change in each line. And that's called the rate of change. So this is asking us, what is the rate of change for each of these graphs? In other words, for each additional pizza, how much is added? So how much does our graph go up every time we get another pizza? How much does it go up for going over 1? How much does it go up for going over 1? How much does it go up for going over 1? And you'll notice it is the same in each of these, right? In each of these cases, no matter how many pizzas you buy, the rate of change, ROC, is equal to 7, because that is the cost per pizza. Every time you go over the number of pizzas, it goes up $7. No matter which graph it is, even though this one crosses the y-axis at 0, 5, still the cost of each pizza is $7. And you can see that right here in the equation. That's that part that is multiplied by the x. 7 is the coefficient of x. So that brings us to question B that asks, for the proportional situation, and that's the first one, how can you identify the constant of proportionality? Well, it's easy to see in the algebraic rule or the equation. The constant of proportionality, the COP, happens to be the coefficient of x. It's that number, these are math words, it's the number that is multiplied by x. That's what a coefficient is. The number multiplied by the variable x. And in this case, 7. All right. Remember, if you have a question about anything I'm talking about, please feel free to type a question into the chat and I'll stop the recording and address your question. Okay. So remember, let's go back and review this super quick here. Whoops, what the heck just happened there? All right, make sure that I'm still sharing the right screen. Yes, I am. Remember, when we go back and we talk about tables and graphs and algebraic equations, if you want to find the COP, if there is one, it's when you divide y by x, that equals the constant of proportionality. And this one, it's 7. You can see it. The input and the output. So the output, which is the cost, divided by the input, which is the number of pizzas. When you divide them and they are the same, you get the constant of proportionality. And also when you're looking at the graph, if it's a proportional relationship, when x is 1, the y value is your constant of proportionality. In this case, it is 1 comma 7. Right there, that's the COP, the constant of proportionality, when x is 1. Y is the constant of proportionality. And again, when we're looking at the algebraic rule, the coefficient of x is the number that is multiplied by x. In this case, 7. 7, 7, 7. 3 different ways to find the constant of proportionality, as long as you have a proportional relationship. Okay, well, that moves us on to question number 3. That says the values in the tables represent points on lines. So these are ordered pairs. And so what we're going to do with these ordered pairs is we are going to graph them. Now, letter A here says when a relationship is proportional, you can multiply the input value to get the output value. Which tables represent proportional relationships? So remember, if you can multiply the input, okay, if you can multiply the input to get the output, so remember, that's the y equals kx, right? That's the input multiplied by something to get the output. But you also have to remember that when you divide y by x, you'll get that same constant. So it's really easy. You can tell which one of these is proportional by dividing your y value by your x value. So let's look at table A. 4 divided by 0 is 0. 11 divided by 1 is 11. 18 divided by 2 is 9. Do we have a constant there? Is it the same every time? Are the quotients equivalent? No. So that is not proportional. Not proportional. I'll just make a note of that. That's, oh, you know what? Let's try to make that a little bit neater. Not proportional. Okay. Let's take a look at B. If we divide y by x, 0 divided by 0, well, we know that, first of all, that's looking pretty good because it's going to go through the origin. 7 divided by 1 is 7. 14 divided by 2 is 7. So you get 7 each time. So we know that this one is proportional. Great. Let's take a look at table C. 7 divided by 0 is 0. Okay. 750 divided by 1 is 750. $8 divided by 2, well, that's $4. Well, those are different numbers. When you divide, they have to be the same. So not proportional. Okay. And let's take a look at D. Whoa, that's a thick, heavy line there. That's all right. 0 divided by 0. Well, it's going through the origin. That's good. These all went through the origin, but they weren't all proportional. So that's, worrisome. Let's look at this. 2 divided by 1 is 2. 4 divided by 2 is 2. So far what we're looking at here is every time we divide y by x, we get the same constant. So this one is proportional. All right. So now that we've taken a look at all of them, the first question says, which tables represent proportional relationships? Well, that would be table B and table D, because when you divide y by x, we get that constant every time. All right. Now, the next part says when a relationship is non-proportional, you cannot just simply multiply by the input value to get the output value. So that means when you divide the y by the x, you're not going to get that constant either. So which tables represent relationships that are non-proportional? Well, look at that. We've already figured that out. Sweet. That would be tables A and C. Those are not proportional relationships. All right. Now this next part may take a little bit of doing. It says to graph the points from the tables. So I'm going to graph the points from the tables, and it says to do them in different colored lines. So that'll be fun. We got this. And we'll take a look here. So in our first, you know what? I'm gonna have to shrink my view down just a little bit so I can see the table and the graph at the same time. There we go. Got it. And I will switch and use my mouse, which will be a little bit easier. All right. So the first one, we're going to graph A. So A is, the first point is 0, 4. So it's 0, there's 2 and 4. Oh, you know what? I'm going to have to thicken that line up. There we go. Close. All right. And 1, 11. So 1, there's 10, 12, 11 must be about there. All right. And 2, 18. So 2 up to 18. Now I can draw a line through there using my drawing tools. This, of course, will be easier for you because you'll be using, if you've got your book, you'll be using a paper and pencil. Just make sure that you make sure you're using different colors. All right. Now my next one is B. Oops, and I got to label that one. So I will label that one as A. Okay. Now B is a different one. So I got to change my thickness here. That'll work. B is 0, 0. Okay. And 1 and 7. So there's 6, 8, 7 would be about here. All right. And 2, 14. 2, 14. Okay. Now I'll draw my line through them using my shapes. Here we go. Okay. That is B. C has to be drawn in red. All right. So here we go. 0, 7. So here's 0, 6, and 7. There we go. And 1 and 750. Okay. And 2 and 8. Okay. Change the thickness of my line. Draw my line. There we go. Okay. And that is C. And the last one is D. And that'll be in orange. Let's see here. Orange. Nice thick dots there. Orange. Beautiful. 0, 0. And 1 and 2. So there's 1 and 2. And then 2 and 4. 2 and 4 right here. Okay, now I can draw my line. Starting at my origin, up through there. Okay, and that's D. Whew. Now, got my 4 different lines in 4 different colors. Make sure that we understand that that one is A. This one doesn't really, there we go. Easier to see. Now, which graphs represent relationships that are proportional? Well, it's pretty easy to see which ones are proportional because first of all, it's B, the line that represents B, and D, because they are straight and they pass through the origin. That's how we know a graph, a line on a graph represents a proportional relationship. It is a straight line passing through the origin at 0, 0. All right. Beautiful work. Okay. That seems like a really great place to stop for today. And we will stop the recording here.